Hello class, these are our informal geometry notes for section 2.3. So today we're talking about complements and supplements. So two angles are complementary if they, guess I gotta get my pen here, if they add to 90 degrees. So two angles that add together and make 90 degrees. Complementary angles always occur in pairs. So one 90-degree angle cannot be complementary, or three angles that add to 90 cannot be complementary. It has to be two angles. So first we're going to go through and look at all the pairs of angles that are complementary. So that means we're going to check to see if they add to 90. So 60 plus 30. This one makes 90, so let's go ahead and circle this one. 40 plus 52. That makes 92, so not this one. 63 plus 27. So let's see, 10, 60, 70, 80, 90. Okay, so complementary again. And the last one's kind of a trick question. It does not give us angle measures, but we do have a box here in the corner of both of these angles together. So angles 1 and 2 form that box. And remember that box stands for a right angle, which is 90 degrees. So the last one would be considered a pair of complementary angles as well. So don't forget stuff like that. So two angles are supplementary if they add to 180 degrees. And they also occur in pairs. So now we want to go through again, same idea as last time, and we want to check and see which pairs are supplementary. So we're going to try adding them up. So 120 plus 60 makes 180. So this is going to be supplementary. I can also tell because they form this straight line together. On the next one, 130 plus 50 adds to make 180, so supplementary again. Then we've got 140 and 52. So those add to make 192. So this one is not supplementary. And the last one, it doesn't give us angle measures, but again, angle 1 and angle 2 are forming a straight line. So here's that straight line here that they're forming. And so that's automatically, straight lines are 180 degrees. That's a straight angle. And so it is automatically supplementary. So our last vocab word for the day is adjacent angles. So angles are adjacent if they share a vertex and side. So let's just draw a quick picture. Here are two different angles that are adjacent because they are sharing. Let's go ahead and mark this in a different color here. They are sharing a vertex here and a side. So here's the vertex that they're sharing. Here's the side that they're sharing. So this one is a picture of adjacent angles. So angle 1 and angle 2 would be adjacent. So angles that are not adjacent would be like this angle 1 over here, and then angle 2 is over here. They are not connected to each other. They do not share a vertex or side. So we're just going to go back up through and label whether they are adjacent or not. So let's just use the letter A for adjacent, and I'll use this other color. So when I'm looking at these complementary angles, and it doesn't matter if they're complementary or not, adjacent's different, right? So this first one, we are sharing a vertex, and we're sharing a side. So this would not be, so this would be adjacent, sorry. Next one, they don't have anything in common, they're not connected, so they're not going to be adjacent. Same thing on the next one, we have one angle over here, one angle over here, they're not adjacent again, but on the last one I am sharing a vertex and a side, so this one's also adjacent. So let's go down to that next set, and it looks like we've got a couple more adjacent angles. So this first one here, That one was adjacent. And two separate angles on this one, two separate angles here, but this last one that was supplementary was also adjacent. So hopefully that gives you a good understanding of what the word adjacent means in math. So now we're going to go through and we're going to find our supplements and complements. So if I am finding it says the complement of an angle here. Remember, a complement means they add to 90 degrees. So adds to 90. So the long way of thinking this through is to say, well, I want to find the angle. If I take and add whatever that angle is to 32, I am going to get 90. So how do I get that angle? Well, I would need to subtract from 90. And I could look at it as solving an equation. And this would make 58. And so my complement would be 58 degrees. So the short way that many of you will figure out is I'm just really taking and I'm subtracting from 90. I've also had students tell me that they can just kind of look at this and think about how many more degrees they would have to add to get to 90. And so they swear they really are using addition and not subtraction to come up with the answer. So our first one's 58. We do 90 minus 32. Next one we do 90 minus 72. It's 18. And the third one, 90 minus 15, is going to be 75 degrees. So we're just subtracting from 90 because we're looking at the complement. So now for supplements, those are going to add to 180. So now this time we're subtracting from 180 instead. So 180 minus 160 is 20 degrees. 180 minus 85, I don't know what I'm writing there, is 95. So it's going to be 95 degrees. And our last one, 180 minus 18 is 162 degrees. So when we looked at complements, we were working backwards, so we subtracted from 90. And when we did supplements, we were working backwards, so we subtracted from 180. And I say backwards because we weren't adding two things together, right? We were trying to find one of the angles, so we used subtraction. I think this diagram is confusing. It says we want to make three true statements. So what I'm going to start out by doing is telling you, like, look at angle 1 and 2. And when I draw this like little semicircle here, most people look at that and they say, well, angle 1 and 2 are going to add up to 180. So when I kind of draw that half circle, people see, oh, they're forming a straight angle. That's 180 degrees. So if I add up their measures, I get 180. And we could do something similar with angle 2 and 3, couldn't we? So I could look at angle 2 and 3, and I could show the same thing. That's another straight line. And I think for just my purposes, I'm going to write measure of angle 3 first, plus measure of angle 2 is also 180 degrees. So now what I need you to notice about this is I need you to notice that in both cases, we have an angle. We're adding it to angle 2, and it's equal to 180. So the only way for this to be true is for those two angles, angle 1 and angle 3, to be equal to each other. And I just wrote that completely in the wrong order. I don't know what I'm thinking. It's late. I guess I'm tired. So we want to write then that the measure of angle 1 is going to equal the measure of angle 3. So let's think about that again. So we took something, we added it to measure of angle 2, and we got 180. So the only thing different about both of those statements are angle 1 versus angle 3. So those have to be equal to each other. So angle 1 over here is going to have to be equal to angle 3. And we're going to look at that in a couple different ways with a couple theorems here. So first we're looking at the congruent complements theorem. So if two angles are complementary to the same angle, then they are congruent. And they're showing something really similar here to what we did up above. They're saying if I take angle 1 and angle 2, I add them together and I get 90. If I take angle 2 and angle 3, I add them together and get 90. So just like before, they both have a measure of angle 2 and a 90 in them. So then 1 and 3 must also have the same measure, which means angle 1 is congruent to angle 3. So what's going on here is this guy plus 2 equals 90, this guy plus 2 equals 90. So 1 and 3 have to be the same. And then we can do that same theorem, but this time with supplements, which is kind of what we did up in that diagram above. So if two angles are supplementary to the same angle, then they are congruent. And so if I have measure of angle 4 plus 5, I get 180. If I add 5 and 6, I get 180. So they both have an angle 5 and a 180, and that means your angles 4 and angle 6 must have the same measure, and therefore they are congruent. So this is something we're going to work to develop over our work with angles over the next few days, and you'll get better at understanding this theorem. As always, if you need help, make sure you're asking for it in class.